This is a quick review refresher on cross products, also known as vector products, versus the other kind, which is a dot product, or otherwise known as a scalar product. The reason why it's called a dot product is because the symbol that you use is a dot, and the reason you call this a cross product is the symbol is a cross. The one brief comment on vector products. Officially, cross products do not produce vectors. They produce what are called axial vectors or pseudo vectors, but that deals with a reflection property. I personally have not dealt with anything where that makes any difference. It is called a vector product, but just recognize for the purists in the group that it actually produces a axial vector or pseudo vector. Those are just synonymous terms. So if I have vector A and vector B, some angle between them, what I care to do is I want to multiply the components that are perpendicular to each other. So if I think about the two parts here, this is A cosine theta and this is A sine theta. Then A cross B, the magnitude of it is going to be multiplying the perpendicular components. So it'd be the magnitude of A times the magnitude of B times the sine of the angle between them. Now it is producing something that looks and smells like a vector and tastes like a vector if you ever try it. And so the direction, you use the right hand rule. If you're in this form right here, if you're given in polar, use right hand rule. And so you put your hand in the direction of the first vector, so A cross B. Well, A is that way. I want it so that when my fingers bend, they bend towards the second vector. So since that vector is like that, I put my hand like this. My fingers bend towards the second one, and my thumb points in the direction of the resultant. Officially not a resultant, of the product. So this would be into the page. In this case right here. Notice if I did B cross A, that would be out of the page. The magnitudes are the same, but the direction of the vector is different. Where you would have seen this in the first semester course would have been with dealing with torques. That's probably the first place that it usually shows up. Now, just a quick example. If I have 5 newtons at a 30-degree angle, and I do a cross with a 7 meters and a 50-degree angle, then I multiply the magnitudes, so it'd be 5 newtons times 7 meters times the sine of the difference in the angles, which is 20 degrees. This will give me the magnitude of this cross product. 11.97 Newton meters is the magnitude. The direction, well, we need to sort of write it out. Let's establish that as my I and J, I hat and J hat directions. So I have 5 newtons at 30 degrees and 7 meters at 50 degrees. And so this is my sort of, if that's A and B, this is my A and B. Then A cross B is going from the first one to the second one, is going up. And so if that's I, J, K is coming out at us, and so this would be in the K hat direction. If we were given in rectangular form, so if I have 5 newtons I hat plus 3 newtons J hat, cross 7 meters I hat minus 4 meters J hat, then I do my cross product here. So if I have, I'm going to do it out the long way. Let's FOIL. So I have 35. It'll be Newton meters in the end, so I'm not going to write units at this point. 35 I cross I plus outer negative 20 I cross J. I already did that one. Inner plus 21 J cross I. Order matters since I did J cross I here. That's why it's J cross I. Minus 12 J cross J. Note that cross products care about multiplying perpendicular components, and since these are parallel, that's going to be 0 and that's going to be 0. I cross J, well, if we think about our coordinate system here, I have I, J, and then K coming out at us. If I do I cross J, put my hands in the direction of the first vector, bend towards the second vector, my thumb points in the direction of the product, which is in the k direction. So this is minus 20k hat. J cross I, I'm going the other way. J cross I, my thumb points down, so that'll be the negative k direction. So this is plus 21 negative k hat. In other words, the minus sign can come out front, and what we end up with is negative 41 Newton meters k hat. And that would be the cross product from rectangular form. The fact that when I use my right hand, it's one of the right hand rules, use my right hand to do I cross J to be K. This is one of the reasons why this is called a right-handed coordinate system. And so if we do cross products, if I write down IJK, I can write it down again. If I'm going in this direction, it is a positive cross product. That direction, it is negative. So I cross J is K, J cross K is I, K cross I is J. Going the other way, K cross J is negative I, J cross I is negative K, I cross K is negative J. And so that's what that is there. And that's just the quick and dirty on cross products.